Okay. Example 4. Ugh, okay. We have implicit differentiation and implicit differentiation of a quotient rule because our composition function is a quotient. So this will get a little bit messy, but it should simplify down to something reasonable, okay? So chain rule first. On the left, we just have y prime equals the derivative of inverse tan is, where's my sheet here? 1 over 1 plus the inside squared, x over y all squared, multiplied by the derivative of the inside, which is a quotient rule, right? And quotient rule says we start with the derivative of the bottom, y prime, top unchanged, minus the bottom, derivative of the top, did I do the quotient rule? Oh, it's top derivative first. Okay, my bad. Top derivative first, 1 times the bottom unchanged, y, minus bottom derivative, y prime, times the top unchanged, all divided by the bottom squared. There we go. Okay, thank you for that. So this is where it gets messy, right? Because we have a stacked fraction in the denominator, and we have two terms in numerator, denominator, and so we have to multiply all this stuff together. Okay, so when we multiply fractions, it's numerator times numerator, denominator times denominator. So let's just expand it out. Y minus y prime x over y squared plus x squared over y squared times y squared. That actually simplifies, makes our life a little bit easier to just x squared. Does that make sense? We followed that? Okay. So now I want to get the y primes together. Sorry, this should have been a y prime. So I'm going to multiply both sides by the denominator. Y prime y squared plus y prime x squared equals y minus y prime x. And I'm getting the y primes together, getting everything else on the other side. So y prime. Ooh, I have 3 of them. There's another one. Just double check that I wrote that down correctly. Yes, I did. Okay, y squared plus x squared minus x equals y plus x. Beautiful. Thank you for catching that. And our final step, y prime equals y over y squared plus x squared plus x. Awesome. There it is. So a little bit ugly, but, you know, doable, manageable. Question, comments, concerns about this one? We're good? All right, let's move on. Example 5, our last one here. We have a, looks like a quotient rule. However, let's rewrite it. Let's call this arc sine x to the minus 1. So this is a chain rule, right? Our outside function is a power, and our inside function is an arc sine. So y prime equals negative arc sine x to the power of negative 2 multiplied by the derivative of arc sine 1 over square root with a minus or a plus sign, minus x squared. And looking at this, I don't really think there's a prettier way to write this. It's just -1 all over arc sine x times square root 1 minus x squared. Ah, yes, thank you. The arc sine is squared. Yeah, I don't think there's another way to simplify that. That's as good as that one gets. Okay, so homework today is a short one. 10 questions from page 234. You've got the rest of time to work on that. Yes. And I write the restrictions on example 5. The restrictions is this cannot be 0 and this cannot be 0. So x cannot be plus or minus 1. That takes care of the square root. And for arc sine, what makes sine 0? Pi by 2, right? Or n pi, but pi by 2, right? So pi by 2 plus n pi. Sorry, it's just n pi. Pi by 2 arc sine is 1. So 0, 2 pi, 3 pi. Yeah. Example 3 restrictions. Let's go back. Example 3 doesn't really have a domain restriction because cos is defined everywhere. And it's the same thing top and bottom. So the value is 1. It's just whether or not it's positive or -1. This is a jump, a piecewise jump equation. This is saying if the square root of cos squared ends up being positive, then the derivative is -1. And if it's negative, then it's +1. So this is just describing this, right? Because we took the square root of cos squared. So if it ends up being negative, then our derivative is -1. Technically, yes, because it's cos over cos. So it cancels itself out. Do you understand what I'm saying? Yeah? Okay. Was that your last question? Okay, beautiful.